Conductors are used in electronic circuits to carry electric currents between various parts of the circuits. Insulators are used when you do not want currents to get conducted between adjacent components in a circuit. The printed circuit board on which electronic components are mounted have both conductors and insulator. The basic material with which the PCB is made is an insulator with very low conductivity of electricity. The printed circuit on it has high conductivity and is usually made of metals like copper. The insulator between plates of a capacitor is known as a dielectric. Sometimes the dielectric is air, which is also a poor conductor of electricity under usual operating voltages. At high voltages, especially if the distance between conductors is less, air can get ionized and act as a conductor, producing arcing. You may have noted this in high voltage overhead lines sometimes. Current flow through a conductor is measured using an ammeter which is connected in series. The unit of current is an ampere. Smaller values can be expressed as milliamperes and microamperes. The symbol I is used for denoting current in a circuit. 1 ampere can be defined as a charge of 1 coulomb passing a given point per second. An ammeter or amperemeter is a modified galvanometer which draws a small portion of the current in a circuit to produce deflection in a moving coil meter. Now we have digital devices to measure current in a multimeter, which can measure many other quantities as well. An electrical current which travels only in one direction is known as a direct current, while a current which alternates its polarity with a definite frequency like 50 Hz of the main supply is known as an alternating current. Here I am demonstrating the use of a multimeter to measure the current in a circuit. You can see that 1 kilo ohm resistor has been connected to a 9 volt battery, and the multimeter has been set in milliampere range, 20 milliampere range. So it reads 9.11 milliamperes. When 9 volts is applied to 1000 ohms or 1 kilo ohm, the current flow will be approximately 9 milliamperes. That is what you are seeing here. Ohm's law defines the relation between current, voltage and resistance in a circuit, typically for direct current. The current flowing through a circuit is directly proportional to the electromotive force or voltage applied and inversely proportional to the resistance of the circuit. It can be stated mathematically as I is equal to V by R, where I is the current, V the voltage or electromotive force, and R the resistance. Voltage is measured in volts and smaller quantities expressed as millivolts or microvolts. Resistance is measured in ohms and higher values may be expressed as kilo ohms and mega ohms. The formula of Ohm's law may be transformed to V is equal to IR and R is equal to V by I. So if two of the values are known, the third one can be calculated. This circuit also illustrates the Ohm's law, that is the ratio between the current and the resistor. When 9 volts is applied to 1000 ohms, the ratio is E by R is equal to I. So 9 divided by 1000, you get 9 milliamperes.